Thanks very much for having me. I'm Elaine O'Neill. I'm the Director of Science and Sustainability at Quorum. Quorum stands for, you can see that down below, Consortium for Research on Renewable Industrial Materials. It's an organization, it's a nonprofit organization affiliated with 20 research institutions across the US and Canada with a focus on wood and wood products and forestry in terms of understanding their environmental footprint. We've been in existence, it was established in 1996, and I came on board starting as a grad student actually in about 2004 or 5, I think I started working with Quorum, looking at these very issues. My background before that was I was a forest resource professional, a professional forester actually in the province of British Columbia in Canada. And then I did all of this work on the master's and the rest of the work on carbon and forestry and climate change at the University of Washington, ending in 2006. And I've been working in this ever since. So this one, I decided to do a deeper dive into the forest resource accounting because as we went through PCR development, there were a lot of questions and concerns about how did that forest resource accounting actually work. So I wanted to focus on that because I thought that James and Reed could do a really credible and probably better description of some of those other processes. So now you've already seen this particular framework and hierarchy from James, and he's walked through some of that. What I'm going to do is focus on two specific emphasis areas, this a little bit more on ISO 21930, because that's that whole question of how do we know whether or not this system that we're looking at is carbon neutral. And there was also some concerns and a lot of discussion about the regionality of data, you know, the granularity of the data that's currently included in environmental product declarations for North American wood products. Essentially, they come up with a number, an average that's weighted, and I think what we were hearing is that there was some concerns about, well, how much variability is in there? How do you even calculate that? How do you weight it? So I wanted to talk a little bit about that. So I'm going to start with a characterization over time. So the bottom axis here is time, that goes up to 100 years, and then the y-axis is carbon measured in tons per hectare. And this is an example for Pacific Northwest commercial softwoods, and you'll see that in our system, we start at year 0 where we're planting, and then those forests grow through time. You harvest, in this case, it was about year 50, and then you repeat that process. Now, I'd say, if you look at this picture and you don't see an increase in carbon and then a decrease, well, I think you're probably going to need glasses. And this chart really is the whole basis for this concern or this idea that cutting trees creates a carbon debt. The problem is that it's the wrong scale to assess whether the carbon dynamics of forestry because the whole manufacturing infrastructure depends on a steady supply of wood. You need to look at the landscape scale to see how this matters. So if carbon is stable, we can say we're cutting something less than or equal to what we're growing. And so that should look basically flat. If you look at this chart, which is it's actually in a Department of Energy report that we just produced, you'll see that wide fluctuation for a single stand. You know, for a small landscape, maybe 10 forests, you see the narrower fluctuation, and then on a whole landscape, which essentially is what you need to maintain infrastructure, it should be basically flat. That's what you should see. And so that's why we have ISO 21930 as a critical component of the PCR, because it talks about, is this flat, increasing or decreasing? If it's stable, then we can account for the carbon stored in the wood as James has described. Otherwise, we really can't. So this is obviously a representation of what that should look like. In the US, I want to talk about what's actually happening. Now, James had talked about the UNFCCC values for carbon storage in wood and wood products. For me, because my background is forestry, I always like to look at, well, what happens in the forest? And this is data that was taken from Oswald et al. 2019. This represents the forest inventory and analysis data collection from 1953 to 2017, or 1952 to 2016. They kind of report it differently. Basically, they remeasure all of the plots across the country every decade, and they report what the carbon stocks are on those forests. I'm only going to talk about the trees here. I understand that you do have a speaker later that's going to talk about the entire component. That big purple line, that's actually on the other axis. It's on the secondary axis because I wanted it to be close enough to show the distribution. That is the total carbon stocks in the US, softwood growing stocks from 1952 to 2016. This is so consistent with ISO 21930, we can say that the carbon stocks are stable and increasing in the US, and therefore we can apply those methodologies as James described. Now, the interesting thing about this graph, and this again is just for softwoods, if you look at the various regions, you do see a lot of variability. I'm going to talk about two. Now, the major wood producing regions are increasing over time, and they're fairly substantial increases over time in each one of these regions. I'm going to talk a little bit about the other ones. And then we have a couple of outliers where you really see them tanking, and those are essentially a function of bark beetles and wildfire. And it's mostly in national forests driving these trends. That's the Intermountain region and the Rocky Mountain Plains. And then that lower green line that's also tanking is the Pacific Southwest. So that's California forests that are really showing the signs and the impacts in terms of growing stock from some of these climate accelerated outcomes in the forests. So I want to kind of make it a little bit more real. When I talk about those stable and increasing stocks, really it's about investment. And this is an example of investment and how it looks in the Pacific Northwest. I was on a tour with this guy who is about 6'5" and looks like a linebacker. He looks very small compared to that 60-year-old tree of his. This is a result of increasing our management intensity. When we see those increases over time, it's because there was a focus on scientific management and an increase in management intensity. That's how you grow or store more carbon or sequester more carbon per acre. You manage it. This particular case, the forest is certified to Sustainable Forestry Initiative. It also has some other constraints in it. Otherwise, it probably would not be on a 60-year rotation, but it's still part of the company's active harvesting program. So a forest like that would show a trajectory like this example here. And I want to contrast that to another forest in the same region. And this is a forest that had no management. And I know that because it's mine. When it had been harvested probably 30 years ago, maybe, and it was left to come back naturally, and I got a mix of very poor quality alder and some maple that is now falling down. And when you look at the inventory on this forest, you'll see something that looks like that purple line. And I'm actually pretty fortunate to have that purple line. It could look much worse than that, in fact, because what management does is it focuses all of the resources of that acre onto the trees that you're trying to grow in a production system. You can get inventory that looks better, fully stocked, but there's no guarantee of it. So that's really the story of what forest management does in terms of increasing carbon stocks on the forest. And it also explains those pretty significant increases in the wood producing regions. What it really says is that management does matter, and it matters a lot. Now, I wanted to zero in on one particular region, the Southeast region. So that's that increase, that increasing line that I've highlighted in this particular graph. Since the 1950s, they've had both more acres and more trees per acre that are contributing to this increase in carbon stocks. And this is a graph. It's a little bit complicated, but basically look at it from the 40s up to the 2010s. And these are, some of them are like the clonal and biotech work, that's theoretical. A lot of these other things are actually applied. These are the outcomes that we're receiving, nearly a 13-fold increase in carbon sequestration. That's how you're measuring that yield. And then the other important thing is that black line. So whereas in 1940, you would get 1 dry ton per hectare per year, and it'd take you 50 years to get a rotation, now you can get 13 dry tons in about 18 years. So what management buys you is a substantial increase in, focusing all the resources of that acre onto those trees to maximize the amount of carbon, because really the landowners are, in this case, they're interested in producing the wood. The carbon comes along as a byproduct because it's 50% carbon. Wood is 50% carbon. So those are the kinds of improvements that we're seeing that are driven by management. And then Reed will be familiar with this. I borrowed it off of some work that we had done quite a long time ago. And here's what it looks like in a production system where you're looking at the carbon stocks. Now, this is only private forest land. This doesn't include any public forest land, where you have essentially carbon stability on the forest, but yet you've taken off an equal amount of harvest that then gets turned into harvested wood products for use in the built environment and for pulp and paper and other purposes that we use wood for. I want to talk just very briefly about this region, the regions that are showing this incredible productivity decrease. Now, keep in mind that the major wood producing regions are those top 3 lines. So the green and the orange and the sort of deep red. We get most of our wood supply from the Southeast and the Pacific Northwest. In fact, the Pacific Northwest produces about 34% of the saw logs that are generated in the, or pardon me, 34% of the lumber generated in the US comes from Pacific Northwest forests, and it accounts for about 3.5% of the forest land in the state, in the country. So it's like a 10-fold impact on these acres. Now in the Rocky Mountains, much lower productivity, much lower management intensity, and a lot more public lands. So in this particular case, you're looking at the net growth, mortality, and harvest over that same period of time. And the reason for that significant decline is that increasing, the trend of increasing mortality in these areas. And that's, and this is largely, largely focused on national forest timberlands. This isn't reserved lands. These are lands that would theoretically be available for harvest. Now, this is not to pick on our federal partners. It's what it does is recognize that a mandate that largely restricts management can have a really significant negative impact on carbon stocks when we forget that it ends up balancing out current weather and climate parameters. In this case, you know, we've had scientists, fire scientists arguing for 40 years that there's too many trees on these forests and that they will eventually burn, and well, that's really what we're seeing at this point in time. So now I want to shift gears and go into some of the specifics about the data and how it gets derived to help people understand that we're going where we're going with the entire cradle to gate. So you're going to see something like this in an environmental product declaration. This is one from my colleague Maureen Pootman, who is a co-director with me at Quorum. She's the director of operations, and she and James actually work really closely together on putting together these environmental product declarations. And you'll see that there's a total number, and this was just one of her examples we used in another talk. And there's a forest production, so that's the A1, and then the wood production is A2. I want to talk about forest operations a little bit. Now, what goes into it? It depends on the region, but these are some of the examples of things that go into those into that forest operations component of the LCA and then the EPD. If there's planting, then you're going to have the in the upper left, you'll see this, that's actually probably 10,000 seedlings there at a local nursery. The inputs that it takes to take the seed and the seedlings and grow them and then go out and plant them is included. If you have so that's common in the Pacific Northwest and Southeast. Actually, it's common in places where we produce the majority of wood products and where you have a fairly significant management intensity. Some regions, they require you to reduce the fire risk associated with leaving the residues after you harvest. So that's that picture, the next picture. Those kind of happen at the same time. You have to prepare the site before you plant the trees. In many instances, they're going to use brushing and weeding. Here I have an example of aerial herbicide. That again varies by region, and it also varies by ownership within the region. There's some fairly significant differences within them. So the way that we approach this is that we will take a weighted average of all of the owners in that area and the volume of wood that they produce. If they're using any one of these techniques, that gets accounted for and rolled up into a single number. Then of course we have the planting. In some instances we have animal damage control. This is what I call the diaper phase down there in the lower right. Any kind of interim stand management activities. Then we get to this place pre-harvest, and then there's the harvest activity. So within this forest management cycle, you have all of this variability within each region that gets weighted and rolled up into a single number for that region. And then for all of the regions, it also gets weighted. So if 34% of the saw logs or of the lumber is, in the US is coming from the Pacific Northwest, then the weighting of all of that forest management from the Pacific Northwest gets added in and accounted for in that overall North American wide EPD. So then finally, we're going to talk a little bit about some of the alternatives and how we make decisions. And I want to go back specifically to the system boundary. In this particular example, this is something we reported out in a publication that we did in 2017. This is for the Pacific Northwest. We looked at a number of different alternative kinds of treatments, herbicide only, herbicide and pile and burn, and then for historical purposes, because we actually don't do broadcast burning anymore, I also looked at that. And then we measured the inputs, you know, in terms of carbon sequestered per cubic meter of log, the emissions associated with it, and then that net values sitting on the landing. And we did that without considering the burning. because the standard Tracy method, the method that we use for the impact assessment, doesn't require that. And then I included biogenic carbon emissions. And you get this range of numbers, right? If you're burning that slash, you have a range of numbers, but you have to have a mass balance. So if you're burning you either have the slash leaving the product system, or you include it in the product system and burn it. In either case, you get a negative net sequestration because not everything burns. So that's kind of a deep dive into the process of coming up with these regional averages and how we think about carbon on the landscape. And then there's more information. We have 24 years worth of data on our website. Welcome to go have a look at it, and even a few videos where we talk about this kind of stuff as well. So thanks very much.